let's go ahead and work out a problem involving Bayes' theorem. So here I have an example of the people applying for a certain job. We know that 60% are qualified and 40% are not. So based on that info, we can construct a tree diagram. And we are also given that the personal manager claims that she approves qualified people 80% of the time, and she approves unqualified 30% of the time. And we want to find the probability that a person is not qualified if the person was approved. So this involves using Bayes' theorem. So we'll be deriving the formula before finding the probability. So let's go ahead and do that. So we know that 60% are qualified, 40 are not. So let's use Q for qualified and A for approved, which means if I draw a tree diagram, the first branch we're going to draw will be people qualified and not qualified will be Q prime. So this would be 60%, so that's 0.6, and this branch will be 40%, and that sums to 100%. Now the next branch is the conditional probability. So we know the manager claims to approve qualified people 80% of the time. So that's given qualified and you're being approved, that's 80%, which is 0.8. And qualified not getting approved, that will be 0.20 because they sum up to 1. Similarly, we know that also she approves unqualified 30% of the time. So not qualified and getting approved. So that will be the next branch. That is 0.3, 30%. And not being approved and not qualified, that's 0.7, because again, this sums up to 1. Now we're ready to answer the question. So we're looking for the probability that person is not qualified. So that's A prime given if the person was approved, given, so not qualified. So, sorry, I meant to say not qualified, given that the person was approved. That would be probability of Q prime given A. So let's look at it one more time. Find the probability the person is not qualified. So that's Q prime if the person was approved. So Q prime given A. And this, we're going to rewrite it using Bayes' theorem. So this is what the Bayes' theorem is. So if you're looking for probability of, let's say, Q prime given A, that is equal to the probability of Q prime and A divided by the probability of A. That's the conditional probability. Now we know that we can rewrite this probability from the tree we have up here. Probability of A, that's going to be this branch plus this branch right here. So we can rewrite that portion. So we have probability of Q prime and A over the probability of Q and A. So let me write that as plus sign right here, and the probability of Q prime and A. So that will be the probability of A. And let's put the numbers in. So this is really the Bayes' theorem. And now if I plug in the numbers, probability of A and not Q, that's 0.4 times 0.3. So that's the third branch we're looking at. That's this one. So I multiply their probabilities. And then on the bottom, we have the probability A and Q. So that's this one right here. That's going to be 0.6 times 0.8 plus the probability of not Q and A. Well, that's this one right here again. So that would be 4 times 0.3. And then we multiply them together. So on top, we have 0.12 over on the bottom, we have 0.12 and then plus 0.48. That's about if you add them up, you get 0.60. And this will give us 1/5. So that's the probability that the person is not qualified if the person was approved. So using the Bayes theorem. All right, I hope this makes sense.